All right, so on Talking Tesla, this week we talked about what size of an array would you need to run a supercharger, and so I did some math here. It might be wrong, and so it's here for you to check. But here are some of the assumptions I made. Assume like you've got 2 cars per hour, so 2 cars per hour coming through this supercharger, and they're doing about a half charge. So let's say they're doing about 50 kilowatt hours of charge. You've got a big battery, or say a 90 kilowatt battery, and you're going to put 50 kilowatts in it. So that means you'd have 48 events times 50 kilowatt hours. So that's 2,400 kilowatt hours per day of energy that you would be using at the supercharge station. That's about 7,200 kilowatt hours per month. If you go onto one of many different solar estimating sites, and I did it for my area here in Los Angeles, where we have a lot of sun, they said we'd need a pretty big system, 571 kilowatt system. And they said that that system would be about 57,000 square feet. And to put that into perspective, that's about the same size as an American football field, including the end zones, and about 3/4 of the size of a soccer field for those of you that are metric. And the net cost after incentives would be about $1 million. So safe to say that it is way bigger than the solar canopies that you see just over the top of the cars. You need a big, old, huge array to get this done. But you can check it. This is an estimate. All right? But you can check my math and tell me how far off I am. But I think that's about the size you need, assuming these kind of events. And I have no idea how many events are really occurring and how much energy is really being used at these superchargers. We will find out at a later time.